Okay, so here we are on our 8th practice problem. And again, a reminder, if you have not done these on your own, you want to give them a try before you start going through the solutions with videos. Let's get started. A rocket is fired at a speed of 75 meters per second from ground level at an angle of 60 degrees above the horizontal. The rocket is fired towards an 11-meter high wall, which is located 27 meters away. And then it asks you to do something that we haven't done yet, and that is how much does the rocket clear the top of the wall? So we're going to put some question marks in here, but now's another good time that if you wanted to extend this data table and put questions over here, you're welcome to do that as long as it's clear. So let's draw, I'm going to leave lots of space here. Let's draw this. So we're starting at ground. We have some wall over here, and we know that the height of the wall is 11 meters. And then we have a rocket that we're going to fire at an angle. And this has an initial speed of 75 meters per second. And it's launched at an angle of 60 degrees above the horizontal. So it looks like this. It follows a trajectory, we hope it's like this, right? And it says that this is 27 meters. Now, honestly, whether you do it from the face of the wall or to the middle of the wall, it absolutely does not make any difference in the context of this problem. Some people draw their walls like this, and some people draw their walls like that. These are unnecessary complications. Truly, if you do it to the front of the wall, you should be in good shape, and you can think that the wall is like really, really thin. The rest of the stuff is just a complication that we don't need, at least at this point. We could do it later, but not at this point. So I'm going to say 27 meters to the front of the wall, and the front of the wall is 11 meters high, just as the rest of the wall. And the wall, I'm assuming, is nice and thin, so I don't have to kind of deal with it. And what they're asking me to find is this distance here. That's what they're really asking me to find. So let's start with filling in our table. So here is the initial velocity vector. So this is v naught is equal to 75 meters per second. It is at 60 degrees. So v naught y is equal to 75 sine of 60 degrees, and v naught x is equal to 75 cosine of 60 degrees. So we can just plug those right in here. 75 cosine of 60, 75 sine of 60. They're asking us essentially to find a y displacement in order to find out what this difference is. So everybody's really clear on this. No acceleration in the x direction. That means the initial and final x components of the velocity are the same. We have a negative 9.8 meters per second squared for my y acceleration, and my horizontal displacement is 27 meters. Okay, so I need to know how long it takes to get to that wall. And the reason I need to is because if I look here in my y direction, I have absolutely no idea how fast it's going. I don't know, I have no context as to where this is in the shape. I mean, it could actually be right in here to understand. It could be before I reach that point. It could be after I reach that point. I have no way from the context of this problem to determine that. So I only know 2 of my 5 potential variables in the y. So that's why I absolutely need this time guide, because I need to know how long it takes to get to that position. And once I find that, I can use the no VF formula to find out what my y displacement was, and then truly find out what my difference is between the wall height and the top of that displacement point. Okay, so let's go ahead and get solving. So in x, I only have one formula. That's x equals v naught x t. And I need time, so time is equal to x horizontal displacement over the initial component of the velocity vector in the x direction. So 27 meters over 75 cosine 60. Make sure you keep that all together when you divide. Common mistake is to divide by the 75 but not the cosine of 60. So, good habit. 27 divided by open parentheses 75 times the cosine of 60. And you can close your parentheses twice or you can hit enter. And I get a time of 0.72 seconds. I'll give you a second to catch up. Alright, now I'm going to use the no VF formula in the y direction. And the no VF formula looks like y equals v naught in the y direction times t plus 1/2 a in the y direction t squared. So, in the past we had nice zeros that made this lovely. We don't this time. So let's see, we have a mistake. And hopefully this won't happen to you too often, but I'm trying to find, oh no, I don't. For a minute there I thought I was trying to find VF. My apologies. So we're trying to find Y. It's on the left-hand side. This is another reason why I teach you to kind of solve for that on the left-hand side. So I'm trying to find this. So I'm just going to plug in 75 sine of 60 times 0.725. I'm sorry, that's not a 5, this is seconds. Bad handwriting. 7.2 plus 1/2 negative 9.8 times 0.72 squared. Don't drop that square. That's a common error. Let's make sure we practice it so that we don't have that problem. All right, 75 times the cosine of 60, close that parentheses, multiply by 0.72, and then add 0.5 times minus 9.8, watch your signs, don't drop them, times 0.72 squared gives me a displacement, a y displacement of positive 24.459, so it's really 46 meters. So that's my y displacement. I don't need the y displacement. I want to know how much it clears the top. So that's easy. I'm at 24.46 meters. I subtract 11. And the difference is 13.46 meters. So I clear, so my answer is the wall is cleared by 13.46 meters. And that's my answer.